Yeah, good morning, everyone. Um, this is the second problem we are doing this week in the topic time complexity function of algorithms. We're trying to find the efficiency or working out the efficiency of different algorithms. In this program here, this computer program here, pseudocode we call it, the algorithm name is Pilot. And we have an input, that is, we are trying to solve a problem of size, that is the input, of size n. But we're only going to consider positive integers. We don't need real numbers here, complex numbers. We don't need those ones, it's only positive integers. And this is the code you are given. But the question here we are asked to solve, we are only going to look at high operations in this code. Wherever you see high operations, we'll have it at line 2, line 4, line 6, line 7, line 10, line 11, line 13, line 14. These lines are which we consider mostly. That's what the question asks us to do. I have numbered the lines, the code, so that it will be easier for us to see what every line is doing. So I read the question. I haven't got enough space to write the question because the code have already taken the entire board. The question says, let Gn be the number of these high operations, which are executed when the algorithm Pilot is run with input size n. Now the question says, find in terms of n an exact expression for Gn. We have an exact expression for Gn. We are going to find what Gn is. And it has a second part, and hence show that the time complexity of Pilot is theta n squared. So let's look at the first question first. First thing comes first. We are asked to find an exact expression for Gn considering the operation high up. So when you look at the program, let's go through it quickly. Line 1 says count. It's like a counter. Line 1 is a counter, as well as line 9 is a counter. It counts. What is counting? I think it's counting the number of operation iterations. Because here, line 3, we have for j equals 1 to n do. The program, this is a for loop, and what is happening here, the program will continue to run until this condition is met. From j to 1 to n. And what is n? N is the input size. If we say n is like 100, so when it reaches 100, then the program will the loop will stop when it reaches 100, and it will jump to the next operation if there is any other operation. But that is what it means for j equals to 1 to n. Any number you put n, if n is 10, the moment the iteration goes to 10, then the program will either cease to run, or it will jump to the next operation. So that is what the for loop here stands for. So now, and where does it end? Because there is a for loop here, this is the first loop we encountered. So again, look for the last end do. Where the last end do? This is the last end do. So the for loop starts from here to here. Because there is another inner loop here. So this is a nested loop. There is an inner loop, an outer loop. For k equals 1 to n do, and it will do the same thing again with this high up, and it will end in line 8. So the inner loop starts from line 5 to line 8, while the outer loop starts from line 3 to line 12. So now let's find the exact function for this pseudocode. So let's see what is happening. Let's number our lines. And then we'll have g of n here. So, g of n. Since we are only considering the high operations, so line 2, we have high up here. So in line 2, what do we have? This is a constant. It's just a constant, so we put 1. Then we have high up again, line 4. But line 4 is in the outer loop for j equals 1 to k. Line 4, the outer loop, yeah? So line 4 here, there's a loop, but it's 1 high up, so 1 times n, because it means the program will run line 4 over and over and over again because of this condition here, the for loop, the outer for loop here. So the iteration there will take a while. Yeah, so that's why you have 1 times n. We don't know how many times, so it's n. So then line 5, we come to line 6. Line 6. So line 6 again has this loop here, k equals to 1. So now line 6. So line 6 will run 1 times n again. And line 7 again will run 1 times n again. But wait, line 6 and 7, they also have an outer loop, right? It has this inner loop 5 to 8 and also from 3 to 12. So line 6 and 7 means, line 6 and 7, it means they will run 2 different iterations. So because of that, we multiply another n here, another n here for line 6 and 7. Then what do you have? You have line 10 and 11. Line 10 and 11. Line 10 will only run this outer loop from j equals 1 to k. Yeah? So you have 1 times n, and line 11 again, the same thing, 1 times n. And we have line 13 and 14. 13, lines 13 and 14, these are constants, just 1, 1. So now we add. You have 1, the constants, 1, 2, 3. 3 plus the n, 1n, 2n, 3n. You add them. So 3 n's. These are n squared. 1 times n times n, this is n squared. This again, 1 times n is n squared. So you have 1n squared plus 1, another 1n squared. So you get plus 2n squared. So if they ask you to find the exact expression, find in terms of n an exact expression for gn. This is the exact expression for gn. So question number 1 is answered. If you just write it the proper way, the bigger term comes first. So you have 2n squared plus 3n plus 3. That is your answer for the A part. Now let's go to the B part. And the B part says, and hence show that. What does it say? And hence show that the time complexity of the algorithm pilot is theta n squared. Good. So, what is theta n squared? Theta n squared, this is the average performance of the program. Theta n squared is the average performance of the program. Big O n squared, this is the worst performance of the program. So what this question is asking us to show that the program, and hence show that the time complexity of this is theta n squared. For you to be able to show this one, you have to show it against what? They ask you to show that the program is running at its best performance, average performance. So you have to compare it with which other performance? The worst performance. So you have to compare these two. They don't mention this, but the question requires you to do something about the worst performance of the program, which is big O n squared. So now, we got our function. It says g of n, how many minutes? 10 minutes, is equals to 2n squared plus 3n plus 3. So from here, you know that n squared want this. Yeah, they don't ask you about this, but the question is indirectly asking you to do something about the worst scenario this program will run. The worst, when you do time complexity functions of algorithms, they have bounds, upper bounds and lower bounds. Yeah, this is the upper bound, worst case scenario. We are proving it against the average case scenario or the exact case scenario. Yeah, so you know n squared is either less than or equal to 2n squared plus 3n plus 3. This is true for all n equals, for all n greater than or equal to 1. If you put 1 in the place of n, you'll find out that this is going to be 1. And this is obviously now 2 plus 3 plus 3. So it's going to be 8. So it means 1 is less than 8. We'll take the less than case, which is true. That's what you want to prove. So if that is it, then n squared is in O g of n. Yes, this is what you want to prove. You've now proven that n squared is less than or equal to this for all n greater than 1, because n has to be an integer. It has to be 1 or greater than 1, not less than 1. Yeah, the question says n is in the positive integers, so we've proven that one here for all n equals to or greater than 1. So if it is equal to or greater than 1, it means it's all positive numbers. Now we get no negative numbers. So then you've shown here that n squared is in big O g of n. So the first part is proven. Now we need to prove the next part. That is g of n now must be equal to, must be in n squared, O n squared. Let me write it properly. Now we're going to prove g of n must be in O n squared. We have proven n is in we've proven this case. This is the case we've proven. Now we're going to prove the reverse or the opposite. So if that holds, then this program is in theta n squared. Then we've proven the first one. Now these two must hold for this to hold. Now we've proven this one. This is done already. We now got to prove this, which is just the reverse of this. If that holds, then it means theta n squared holds. So I need space now. Then still continue to do it here. So let's continue from here. Continue from here. So now, here, we continue from here, okay? So we now have, this is less than 2n squared plus 3n plus 3n for all n greater than or equal to 1. So this equation now will be 2n squared plus 6n. 3n plus 3n is 6n. We are doing a proof. Yes. So these are mathematical proofs. We've got steps to follow. So it means 2n squared plus 6n for all n greater than 1, yeah? Equal to 1. Don't forget this condition. It's important. Plus 6 plus n squared for all n greater than or equal to 6. So now this will give you 2n squared plus n squared. This is 3n squared for all n equal to or greater than 6. Yeah, the 6, this n goes to the upper bound, n squared for all n greater than or equal to 6. So what you have now here, you have big N equals 6 and C equals 3. So hence, this is telling you now that you have 6n squared. So it's proven. This is now proven that n squared is in G OG of n. So that is the case, then theta of n squared holds. So I'll give my channel, my YouTube channel, because some of these programs, you got to follow me on my YouTube to watch them completely. This problem is not done yet. It has a lot of sub questions which we are going to do. We'll stop here for now, then we'll follow up. Let me just write my YouTube channel. Just go on the YouTube browser, then you type MUNIRMKTURAY. Just type this MUNIRMKTURAY on YouTube channel. YouTube. YOUTUBE YouTube channel CHANNEL. This is what you type. Go to your YouTube browser, then you type this, you will see my my lessons there. Okay, thank you for watching. Bye bye. Have a nice weekend. Bye.